Okay, thanks for the introduction of the chairs. And my name is Zhongxiang from Gaoling School Artificial Intelligence, Renmin University of China. And today I'm going to represent a paper called "To Search or to Recommend: Predicting OpenApp Motivations with Neural Hooks Process." This work is collaborated with the Quattro technology. Yes, it's just as same as the first papers. Yeah. So. I will briefly introduce the background of OpenApp motivation. So what is Open Apps? Open Apps actually happens everywhere. When we are somewhere home, when we are eating in the restaurant, and when we are working at the workspace, we always open some apps. And the red figure is just the unlock statistics of myself, and it reaches such high frequency, let alone the open apps. So nowadays we can't live without using phones or exactly without opening apps. At least that's how I am. So we have noted that open app motivations happens everywhere and anytime. Have you ever wondered why you open some apps or what motivation drives us to open apps? Take myself an example. Nowadays, when we are on the way, I'm on the way home, the way may be so boring, so I may open some music apps to listen some recommended music to pass time. When I'm eating in the restaurant, I may, when the dish is so delicious, I may want to search how to make it. And when I'm working in the workspace, my code may enter a bug, so I may search how to fix it. And so, nowadays, incorporating search and recommendation into the same apps has been very prevalent in online platforms such as TikTok, Quai, and X. So, two primary open app motivations can be enhanced suggestions from the recommendation systems or employ the search engine for information seeking. And our task is just to predict whether user init apps with the specific intent of information seeking or explore recommended content for entertainment. So here we give the user flow through the application uses. When the user pick up phone, the user return prediction text will predict whether user opens the apps, and then our open app motivation prediction will predict why user the apps for recommendation or for searching. And then after user enter the apps, the searching and recommendation systems will retrieve, ranking, and re-ranking the information to give the users related contents. And as we can see, our text is just in the middle of the user retention prediction text and the traditional search and recommendation text. So our text just fills gap in this use flow and making this use flow completion. So someone may ask, predicting users' open app motivation sounds very interesting, but what specific value does it offer? I think the following two experiments may answer this question. The first experiments were done on Quai apps, a short video platform with billions of users. The experiment is when moving the search module from the previous not easy to find place to now prominent place. The rated value of open app motivation to search increased from 0.1% to 0.8%. This is a very big improvement in the business metrics. However, this improvement leads to competitions, and 86.7% of gains is from search. However, 13% from a decrease in returns from the recommended videos. And our solutions can be dramatically adjust the search and recommendation modules by predicting users' open app motivations. If the motivation is search, we can just put this module to the prominent place. And if this motivation is to recommendation, we can just remove that and let the users just watching the videos. And the second experiment was to add the open app motivations learned from our following modules to the underlying applications, which can also lead to very big improvements. And as we have seen the values of the predicting open app motivations, so how to predict the users' open app motivations? We first analyze the behavior patterns of users' open app motivations, and the figure shows the users' studies or users' open app motivations from a structured interview. One major factor influence users' open app motivation must be the user's interest, and then the user may search for the same query or influenced by the periodical features. And then we have static analyze the behavior patterns between OpenApp motivations and find that users' OpenApp motivation exists prevalent periodical, which means that users tend to have a higher search motivation during daily lunch breaks, after working hours, or on the weekends. And besides, users tend to open the apps due to the same query. The more active, the more repetitive, and the average repeat query ratio reached over 10%. Finally, we found that users' last session behaviors influence their next session's OpenApp motivations. The more search actions in the last session, the more probability users open app to search. So, based on the observations, we will begin the introduction of our method. In order to better predict OpenApp motivations and leverage the features we mentioned above, we propose to use a math tool called neural hooks process, a temporary point process that model temporal dependence and complexity patterns or events. And we propose NIPOM by adapting neural hooks process to predict users' OpenApp motivations. The intense function is the core of the neural hooks process. And in OpenApp motivation predictions, the intense function is just represents the probability of search or recommendation motivation. And here we use the linear interpolation and on the neural intensity. We can leverage the temporary dynamic modeling capability of neural hooks process to adjust the intense function to reflect this periodical feature. And the temporal self-exciting mechanism of neural hooks process can help identify and predict users' behavior or repeated query. Finally, we add the relevance score as a bias to induction bias to model the relevance feature. And the history encoder of NIPOM's input is the sessions of items and the corresponding time. The items can be clicked recommendation of search items, and the time is encoded using a sine cosine positional encoding like that. Yeah. The history encoder includes a session level encoder to generate VN representing session intent using transformer encoder. The history encoder generates HN for intense function and long-term history representation using transformer decoder. The final module of NIPOM is the prediction layer. The first reason to add the prediction layer is that the paper from Zhou shows that an additional predicting layer on top of the neural hooks process yields better performance. Moreover, we can add more user-specific features and time information for better prediction to better predict users' OpenApp motivations. The prediction layer contains the time gate to learn the periodical features and concat with the user's embedding for final prediction. And the training process of NIPOM is a multi-object joint optimization, which simultaneously optimizes the maximum of the likelihood or intensity and minimize the binary cross entropy. So, I will show the experiments. And in order to better evaluate the proposed model NIPOM, we construct a new real-world OpenApp motivation dataset called OM. And we intend a public search and recommendation dataset called Zhihua rank. The OpenApp motivation label is search if the user actively search within 30 seconds, and is recommendation if the user does not search within 30 seconds. This classification method is rooted in the platform's comprehensive data analysis and business strategy. And in the evaluation metrics, we use the accuracy, precision, F1 score, and F.0 score, and AUC. The baseline models, we use the sequential recommendation models, joint search and recommendation models, time-aware sequence models, time series model, and the neural hooks process models. And we adapt them to our OpenApp motivation predicting text, such as add an alpha layer to predict the final motivations. And from the results, we can see that the NIPOM just wins the time series models, sequential recommendation model, and search and recommendation sequence models. This shows that the part information was insufficient. When we incorporate time search and recommendation features, we can only predict OpenApp motivations by incorporating time search and recommendation features simultaneously. And we can also find that the NIPOM just perform better than the time series models and the traditional neural host process models. We show that the neural host process models can effectively capture the features in OpenApp motivations, but this is not optimal. Our work in NiPoM performs better through the adaptation denials we mentioned before. And finally, I will give some future directions if you want to follow my paper. And as this is a very new test, so we'll give some future direction. The first is a very simple direction is to add more motivation, such as we can open some apps as a motivation we want to chat with someone, not just search or recommendation. So we can add more optimizations in our task. And the second is modeling when we are modeling the users actions in some agent systems, such as agent for rank, which also received by the SIGIR paper. And we can also model our OpenApp motivation in this simulation agents. Then we may get better performance. And finally, we can construct a more personalized conversational search or recommendation by integrating entity by predicting users' OpenApp motivation. And this is just the ChatGPT's interface. It also has the recommendation and the search. So we can predict the user's OpenApp motivation to give a more personalized conversational interface. And finally, I will give the takeaway you can get from this introduction. And we propose an OpenApp motivation text, which is commonly in day life and holds significant commercial values. And the second is that the neural host process OpenApp motivation model is using the neural host process as this is the intensive function, which is the core of our model. And finally, we can apply the OpenApp motivation to the downstream text and lead to a better improvements. And finally, this is all my contact methods. You can, if you have any big questions or want to have a further collaboration with our groups, you can just scan this. Yeah, thank you.